In this video, let's integrate sine inverse of 2x upon 1 plus x square. Before we proceed on integrating this, let us simplify the problem a little bit. So I want to write x as tan theta, and this will give me dx as sec square theta d theta. And we can also calculate 2x upon 1 plus x square, 2 tan theta upon 1 plus tan square theta. In this form, it's not very useful for me. So let's replace tan theta by sine theta upon cos theta and see what we get. So I will get 2 into sine theta upon cos theta upon 1 plus sine square theta upon cos square theta. Let us take LCM and simplify. So I'm going to get 2 into sine theta upon cos theta upon cos square theta plus sine square theta upon cos square theta. I know that the value of cos square theta plus sine square theta is 1. So I will get 2 into sine theta by cos theta into cos square theta upon 1. And I can also simplify this cos in denominator and numerator. And finally I'm going to get 2 into sine theta cos theta. This is sine 2 theta. And now let's use these three values in the original problem and simplify it. So I can write integration of sine inverse 2x upon 1 plus x square as integration of sine inverse, and 2x upon 1 plus x square we have calculated as sine 2 theta, and dx is sec square theta d theta. Now here you have sine inverse of sine. So these two will cancel each other and we will be left with integration of 2 theta sec square theta d theta. We can also take 2 out of integration and write 2 integration of theta sec square theta d theta. Now here we have got two functions theta and sec square theta in multiplication, and therefore we are going to use integration by parts. So we are going to use integration by parts. So we are going to select the first function and second function so that the first function is easy to differentiate and second function is easier to integrate. So I am going to select the first function as theta and the second function as sec square theta. And we know that integration by parts says that integration of two functions f of x and d of x can be calculated as first function into integration of second function minus integration of second function into differentiation of first function and whole dx. Now here our functions are in the here our functions are in terms of theta. So we can write that integration of theta sec square theta d theta is, so f of x, that is first function, which will be theta, into integration of second function, which will be integration of sec square theta d theta, minus integration of sec square theta d theta into differentiation of theta and whole d theta. Let's also call this equation as equation number 1. So before we proceed any further, we need to find out two values, that is integration of sec square theta and differentiation of theta. So we know that in the differentiation of tan theta is sec square theta. And since differentiation is opposite of integration, so therefore integration of sec square theta will be tan theta plus c. Also, the differentiation of theta with respect to theta will give us 1. So, let's use these two equations, equation number 3 and 4, in equation number 2 and proceed further. So, putting 3 and 4 in 2, we get integration of theta sec square theta d theta as theta into tan theta minus integration of sec square theta from 3 it is tan theta into 1 and d theta. So we need to calculate integration one more time before we can proceed further. Let's call this equation number 5. So we need to calculate integration of tan theta. Now we know that integration of tan theta is minus log of cos theta plus c. So I will give a link for calculation of integration of tan theta. Here we use integration by substitution to calculate this. Watch that video for clarification. So let's call this equation number 6 and put 6 in 5. So we will get integration of theta sec square theta d theta as theta tan theta plus log of cos theta plus c. Now we need to express this equation back in the form of x. So first let us call this equation number 6 and put it back in equation number 1. So equation number 1 was this. So original problem is this and we are calculating this part. So let us put the value of 6 in 1. So we will get integration of sine inverse of 2x upon 1 plus x square as 2 into this whole term. So 2 into theta tan theta plus log of cos theta plus c. Now if you remember we had taken x as tan theta, right? So before that let's call this equation number 7. Since x is tan theta, so we can calculate theta as tan inverse of x. We know that 1 plus tan square theta is sec square theta. So from here we will get 1 plus tan square theta as 1 upon cos square theta. And so from here we can calculate the value of cos theta. So cos theta will be 1 upon square root of 1 plus tan theta. And we also know that tan theta is x. So we can write this as 1 upon square root of 1 plus x square. Let us call this equation number 9. So let us put equation 8 and 9 in 7 to simplify further. Put 8 and 9 in 7. So you will get integration of sine inverse of 2x upon 1 plus x square dx as 2 into, so theta is tan inverse x into tan theta. So tan theta is x plus log of cos theta. So cos theta we have calculated. So using 9 it will be 1 upon square root of 1 plus x square plus c. So we can also simplify it a little bit further. We can open the brackets and see what we get. So let's take 2 inside. So I can write this as 2x tan inverse x plus 2 log, and this power I can write as minus 1 by 2 since it is in denominator. So this can be written as log of 1 plus x square raised to minus 1 by 2 plus c. We know that when the term with log is raised to a power, that power can be written in front of log. So this can be written as 2x tan inverse x plus 2 into minus 1 by 2 log 1 plus x square plus c. So these two, one in denominator and one in numerator, will cancel each other and we will get 2x tan inverse x minus log of 1 plus x square plus c, and this is the final answer. So we have calculated integration of sine inverse of 2x upon 1 plus x square as 2x tan inverse x minus log of 1 plus x square plus c. I hope you understand why we have not used modulus symbol here. Mod is used because log can be calculated only of positive numbers. Now x square is positive, and when 1 is added to an already positive number, that number will always remain positive, and therefore you can remove the modulus sign. Here we have used integration by parts, but first we have modified the problem to suit our But first we have simplified the problem so that it becomes easier to simplify. We have also used integration of tan theta. That link I will provide. Please watch it to understand how we get the result of integration of tan theta. Keep practicing. Let's meet in the next video.